Okay, let's dive right in. For today's deep dive, we're going really fundamental. We're looking at a specific piece of hardware.
We are. It's the Thor broadcast F-PLC-1x16 fiber optic coupler.
But it's not really about this one box, is it? It's about using it as a lens to see the guts of the network, how light actually gets split and delivered.
Exactly. Our mission here is to pull out the key nuggets on two things. First, how signal splitting actually works. And second, something that's super practical, the different types of fiber connectors.
The stuff that actually plugs in.
Right. By the end of this, you'll understand the real infrastructure behind your internet connection.
Okay, so this FPLC 1x16, it's an optical splitter. Simple as that. It takes one fiber input and turns it into 16 outputs, a 1:16 split. And it looks like serious gear. It's designed to be bolted into a standard 19-inch rack.
Yeah, it's just one U, so one unit of rack space. And its performance is what really defines the quality of the network downstream.
So let's talk about that. The spec sheet highlights low insertion loss, 4 decibels. What did that actually mean for the signal?
Think of it like water pressure in a pipe. Every time you add a joint or a splitter, you lose a little bit of pressure.
Okay.
Low insertion loss, just 4 dB, means you're losing a very, very small amount of signal strength. That's critical for keeping data speeds high over distance.
The source also mentions good uniformity. Why is that so important when you're splitting a signal 16 ways?
Well, uniformity is about fairness, really. It ensures that the signal going to output 16 is just as strong and clear as the one going to output 1.
So without it, some users could get a perfect connection and others would get something much worse.
Exactly. It's about stable and equal bandwidth for everyone connected to that splitter.
And speaking of stable, this thing is built for some pretty extreme environments.
Oh, yeah. The operating temperature range it's huge. We're talking minus 40 degrees Celsius.
Oh, that's cool.
All the way up to a scorching plus 85 C. These aren't always sitting in a nice air-conditioned room.
So they're out in the field, in a cabinet on a telephone pole, maybe?
Could be. And it conforms to carrier grade standards, TLC certified standards, so it's built to last in those conditions. And you should note, they scale up too. You can get these in configurations all the way up to 2x64.
Okay, so it's tough.
Yeah.
But you still have to physically plug into it. This brings us to the connectors.
Yes,
Yeah.
the connectors. They all do the same basic job, but in very different ways. The key part is the ferrule.
The ferrule, right. That's the tiny little ceramic sleeve that holds the actual glass fiber.
Precisely. The main differences between connectors really just come down to the ferrule size and how the thing locks in place.
Let's run through the big ones then, the ones you'd actually see today.
The two you'll see most are LC and SC. The LC connector is all about density. It has the smallest ferrule, just 1.25 millimeters,
Tiny.
and it has a simple snap-in lock. It's small, so you can cram a huge number of them onto a single panel in a data center.
So if LC is smaller and better for density, why on earth would anyone still use the bigger SC connector?
That's a great question. The SC connector uses a larger 2.5 millimeter ferrule, and it's also a snap-in push-pull type.
So it takes up more space.
It does, but it's much easier for a technician to handle, especially if they're wearing gloves or working in a tight spot. It's just more robust and easier to patch quickly. It's a trade-off. Ease of use versus density.
So what about the older types like ST and FC?
You still see them, but they're becoming less common. The ST has that twist lock like a bayonet, and the FDC is a screw-on type.
So more work to connect.
A lot more. And in modern high-volume networks, the time you save with the snap-in LC and SC connectors, it just adds up. It's too valuable.
Okay, so we have this tough little splitter with these different ways of plugging into it. Where does this all come together in the real world?
This little box is basically the distribution engine for broadband as we know it. The source lists all the big applications.
Fiber to the home, FTTX?
Fiber to the home, passive optical networks, so PON and GPON, even for things like local area networks and cable TV.
So this is the device that lets one main fiber line from the central office serve an entire street or building.
That's it exactly. It's what makes rolling out high-speed internet to whole neighborhoods economically possible.
So, to sum it up, these splitters are the unsung heroes, routing light with almost no signal loss. And the connector you choose is actually a big strategic decision.
It is. Density versus convenience. And that brings us to a final thought for you to chew on.
Go for it.
If a single passive box like this, a 1x16 coupler, can handle a temperature swing from -40 to +85 degrees Celsius while splitting a perfect uniform signal, What does that extreme level of hidden robustness tell us about the foundational quality that's required to keep our entire nationwide broadband infrastructure up and running 24/7?
Something to think about next time your connection just works. That's all the time we have for this deep dive. We'll see you next time.